Okay, Algebra 1 fans, our topic for today, this is section 4-4 and 4-6. We're going to combine a couple topics here. Scatterplots, lines of best fit. And after this lesson, our objectives, you should be able to analyze a scatterplot and find a line of best fit and make predictions based on data. And before we begin, let me give you your joke of the day. Why did the student eat his homework? Because the teacher told him it was a piece of cake. Get it? Piece of cake? All right, so we're going to start here with a table of information. We have the year, and from 1950, we're going up by 10 years all the way up to 2010. And then below that is the world population in billions. So in 1950, the population of the world was 2.5 billion people. 1960 was 3 billion. By 2010, it was 7 billion. Now, in this case, the year is going to be our x variable, and the population is going to be the y variable. And one of the things that we like to do with data is we want to look for trends. Is something happening with the data? Is there a relationship between these two variables? And one thing you might notice is that as the year increases, the world population is also increasing. So that's kind of interesting. That's a general trend. And the question is that going to continue? So we've got the chart above. And what we're going to do first in part A is we're going to graph the ordered pairs on the coordinate plane below. This is called a scatterplot. Okay, so scatterplot is a graph showing the relationship between two different sets of data. So the different sets are the year and the world population. So we can look at the numbers and we can tell as one thing is increasing, so is the other variable. The population is also increasing. But it doesn't tell us as much as if we actually have a picture that we can look at. Okay, so they say a picture is worth 1,000 words. Well, when we're talking about data, we want to graph data because we want to look at it and because it's going to give us more information. So we're going to graph this. The x-axis is going to be the year, and the y-axis is going to be the population in billions. So we're going to take, now our ordered pairs are for the year and for the population. So 1950 and 2.5 is the first point. So we're going to go 1950. Now 2.5 is halfway between 2 and 3, so we'll put it right there. And then the next one is 1960 and 3. So when the year was 1960, the world's population was 3 billion people. 1970 was 3.7. Now some of these we're going to approximate. 1970, now 3.7 is between 3 and 4, but it's higher than 3.5. That would be halfway, so I'm going to put it right about there. And then 1980 is 4.5, so halfway between 4 and 5. 1990 is 5.3, so a little bit less than 5.5. 2000 is 6. 2010, the world's population was 7 billion people. All right, so we look at that, and now think about what you're seeing here. Is there a pattern to the data? So not only is this increasing, as the year increases, the population is increasing, but doesn't it look almost like a straight line? Now you may look at this and say, well, actually, I think it might be more of a curve, because one of the things that happens, if we go back to the table, the population is growing, but it's not growing at the same rate every 10 years. The growth from 1950 to 1960 was 0.5 billion, half a billion people. But from 60 to 70 was 0.7 billion people. And then 0.8, 0.8, and then 0.7. But then from 2000 to 2010, it really grew fast, 1 billion people. So the rate of change is not always the same. However, this certainly looks very, very linear. It may not be a perfect line, but it is pretty close. Okay, so by graphing it, we get to see that. That's why graphing is so important. So we're going to answer some questions here. What is the general trend of your data? Well, we've already kind of talked about this. As the year increases, what happens to the population? Well, as the year increases, population also increases. We would say, because as you are looking at this from left to right, the y values are increasing. This would be a positive slope if we were calculating slope. So we would also say this is a positive trend, and it is also linear, strong linear. Now, another word for the trend is what we call correlation, the relationship between the data. In this case, it's very strong. That means that the points, if we're saying this is a linear pattern, the points are very close to a line. Okay, they may not be perfect, and it doesn't look like it would be that I could draw a line that goes through all of them, but that's a pretty strong positive trend. So the correlation would be what we call positive. Now in part C and part D, they say make a prediction for the world's population in the year 2050 and then in the year 2100. So one of the reasons why we analyze data is we are looking for current trends, but we're also looking to see what do we think is going to happen in the future? How is this going to play out? Where will the population be in the year 2050? Where will the population be? Now we're actually going to run off the graph here, but in the year 2100, how big will the world's population be? Will it continue to grow at this rate? And if it does, how high will it be? Now, we could guess, we could kind of eyeball this and make an estimation about that. But something else we can do is try to fit the points to a curve or a line. In this case, we'll use a line. So I am going to draw a line that I feel represents the data, okay, that represents what's happening. Now, some people might say, well, let's just connect the first and the last point. Okay, we could do that. And it probably wouldn't be bad, but notice that most of the points would be off of the line, okay? It wouldn't, what I really want to do is have a situation where about half the points would be on one side of the line and half the points would be on the other side of the line. I'm not going to use this point because this is the one that seems to be off. If I tried to draw a straight line, this would be the outlier, okay? That probably wouldn't be on the line. So I'm not going to start with that point. I'll take the 1960 and 3 and I'll connect that to our, let's see, right about, let's go through there. Okay. Now, different people may connect this differently. I wasn't even taking, I'm using this point here, but I'm actually using 2005, and this would be 6.5. I didn't want to use the last point. I didn't think that was the best. So what I'm drawing here is called a line of best fit. Line of best fit. I am trying to fit the points to the line. Now, because this is not perfectly linear, not all the points are going to be on the line, but I want them to be as close as possible, okay? So the 2 points that I was using here, I did 1960, 3. Let me write that in red, that'll stand out a little bit better. 1960, 3. And I did 2005, 6.5. If I had done 2010, 7, that would probably look pretty good as well. So here's my line of best fit. Now, if I continue this, So I'll keep connecting here. And I'm actually going to even run off. I'm going to run off the page. If we want to make a prediction in the year 2050, I'd go up. Here's my y value, and that is approximately 10 billion. So if this trend continued, 10 billion people would probably be a good estimate. 10 billion is the number 10 with 9 zeros. That is a lot of people right there. Now, in the year 2100, I'm actually going to have to extend my graph here. There's 2100. Now what I would do is I would just look up and I would see, okay, where do I go through? Well, I'm way up here, which is also off of the y-axis. So if I extended this, somewhere over there, okay, so this is not very scientific, but there's 13, yeah, it's about 14. Okay, about 14 billion people. That would be my estimate. Okay, those are my estimates for the world's population. Now that is assuming that this continues. There are many factors which might cause this graph to change. On the bad side, it could be global warming, it could be a food shortage, it could be disease or war, and suddenly these points may not be as high. Or if our technological advances keep increasing, maybe we can support, maybe the planet can support 10 billion people or 14 billion people. So there are different things that you can think about for this. All right, so we're using the scatter plot here to try to explain the data, what's happening, and to make a prediction of what we think will happen. Now, in the second part of this, we're going to try to do this a little bit more mathematically. We're going to come up with an actual equation, and then we will see how accurate our estimates are. So that is the end of part 1.